Hello, guys. So this right here is our Maclaurin series as we derived from the previous class. So this Maclaurin series may be used to represent any function f of x as a power series, provided that the following conditions are met. So the first condition, provided that at x is equal to 0, these conditions are met. The first condition is that f of 0 is not equal to infinity. The second condition is f prime of 0, f double prime, the derivatives are not equal to infinity. And finally, the resultant Maclaurin series must be convergent. In general, this basically means that the values of the terms or groups of terms must get progressively smaller. So for example, something like this, if we have a series like 1 plus a half plus a quarter plus 1/8 plus goes on and on. This is a convergent series since, as we can see, the values of the terms are getting smaller, okay? Smaller, and the sum of the terms is approaching 2. Is approaching some limiting value 2. Okay, fine. So taking up examples, let's determine power series of a few functions. So determine the first 4 terms of the power series. Example 1, determine the first 4 terms of the power series for cos x. Now, since we are using the Maclaurin series, I want to write it here. F of x is equal to f of 0 plus x, f prime of 0 plus x squared over 2 factorial, f double prime of 0 plus x cubed over 3 factorial, f third prime of 0 plus it goes on and on. They want us to get the first 4 terms. So 1, 2, 3, 4. So this is enough to give us the first 4 terms. Now, our f of x in this case is given by cos x. This is what we want to expand and write its power series. So clearly, we start by evaluating it at f of 0. So what is f of 0? When x is equal to 0, this will be cos of 0. And what's the value for cos 0? Cos 0 is 1. Now, what's f prime of x? Differentiating cos x, we get minus sine x. So what is f prime of 0? Replacing 0 here. So we will get minus sine of 0, and this will give us 0. Okay, fine. So you might need probably more terms because, as you can see, that term is going to be 0. So let's say this would be x raised to power 4 over 4 factorial f fourth prime of 0 plus x raised to power 5 over 5 factorial f fifth prime of 0 plus x raised to power 6 over 6 factorial f sixth prime of 0. So it goes on and on. It goes on and on. So I would like us to have at least 4 terms. Now, what is f second prime? The second derivative, if we differentiate minus sine x will give us minus cos x. And f second prime of 0, if we replace 0 here, that is minus cos x, cos 0, and that will be minus 1. Okay, the third derivative, differentiating minus cos x, that will give us positive. That will give us positive sine x, and if we replace 0, that will just give us a 0. Okay, then finding so we only have 2 terms so far, because if we are to replace these values, then we will have zeros there. So finding the fourth prime of x, differentiating sine x, we get cos x, and then f prime, fourth prime of 0, f fourth prime of 0, if we put 0 here, that will give us 1. So we have 3 terms so far. And then fifth prime of x, differentiating cos x, we get minus sine x. And this f fifth prime of 0 will give us a 0. And then f sixth prime of x, differentiating minus sine x, will get minus cos x. F sixth prime of 0 will give us, if we replace 0 here, we'll have -1. So clearly, if we come and replace these values into our Maclaurin's series formula, we'll have our f of x, which is now our cos x, in terms of power series given by f of 0, and our f of 0 is 1, plus x f prime of 0, this second term here, but our f prime of 0 is 0, so the whole of this term will just be 0, plus now we have x squared 2 factorial f double prime. And what's our f double prime? Our f double prime is -1, so this will just be negative. So negative x squared over 2 factorial plus, so we are here, the third prime. So looking at the third prime is also 0. So clearly that term will be 0 as well. The fourth prime is 1. So replacing it here, we will have plus x raised to power 4 over 4 factorial. The fifth term is 0 as well. So this term will not be there. And the fifth term is -1. So we'll have minus the sixth term, x raised to power 6 over 6 factorial. And we just needed the first 4 terms, 1, 2, 3, 4. So that's basically how we determine the power series of cos x using Maclaurin's series or Maclaurin's theorem. Let's take up another example. Let's take up another examples. So let's say determine. So determine the first 5 terms of ln 1 plus x. Okay, using the Maclaurin series. So we want to write the power series of ln 1 plus x. Now we already know the Maclaurin series formula is given by f of 0 plus x f prime of 0 plus x squared over 2 factorial f double prime of 0. So we always have to remember this formula because it's going to guide us in evaluating each and every question. Now, in this case, our f of x is the function that we've been given, which is ln 1 plus x. So we first of all start by getting f of 0. What's our f of 0? If you replace 0 here, you'll have ln 1. And what is ln 1? ln 1 is 0. So our f of 0 is equal to 0. Then we go straight ahead to differentiate. What is the derivative of ln 1 plus x? So that will be 1 plus x, all this divided by 1. So what is f prime of 0? Replacing 0 here, we will have 1. Okay, I want to continue here to save space. What is f second prime of x? Differentiating this function here, so I can decide to write it like this so that I use the chain rule. So I can decide to write this as 1 plus x raised to the power -1. So differentiating this using the chain rule, I'll have -1 into 1 plus x raised to the power of -2 multiplied by the derivative of what is in here, which is 1. So that will be its derivative. And f double prime of 0, if we replace 0 here, then 1 raised to the power of anything is 1. So we'll just get -1. F third prime of x. So we need to differentiate this function here. Now differentiating this function here, this will give us 2 into 1 plus x raised to the power of -3 multiplied by the derivative of what is inside, which is 1. So f third prime of 0, replacing the value of 0 here, we will just remain with 2. Okay, f fourth prime of x. Differentiating this, still using chain rule, this will be -6 into 1 plus x raised to the power -4 multiplied by the derivative of what is inside, which is 1. So f fourth prime of 0, if we replace 0 here, this will just give us -6. Okay, fine. What of f fifth prime? So I'm using the short form chain rule to differentiate this. F fifth prime of x, differentiating this, we'll have 24 into 1 plus x raised to the power minus 5, multiplied by the derivative of what is inside, which is 1. So what is f fifth prime of 0? Replacing 0 here, so this will just give us 24. Now, how many terms do we have so far? This was 0, so we'll start counting from this one. 1, 2, 3, 4, 5. So we already have enough terms. So the next thing is just to replace it into the Maclaurin series formula, and we have our power series expansion. So our f of x is ln1 plus x, and its expansion is given by f of 0, which is 0. We don't need to write it though, plus x f prime of 0. So x f prime of 0 is 1. So we just have x, plus f double prime of 0 is minus 1. So we'll have a minus there. Minus. So f double prime is minus. So we'll have minus x squared over 2 factorial f double prime of 0. Then f third prime is 2. So we'll have plus 2 and f x cubed over 3 factorial. Oh, just a minute. So this is x squared over 2 factorial. We've already replaced f double prime of 0 is minus 1. So I don't need to write that. So f double prime, we've already replaced it. It's minus 1. So next term, we have our f third prime is 2x cubed 3 factorial. Our fourth prime is minus 6. Then we have x raised to power 4 over 4 factorial. Our fifth prime is 24. Then we have x raised to power 5 over 5 factorial. So we could go ahead and simplify this. So that we have our ln1 plus x is equal to x minus x squared over 2. 2 factorial is 1 times 2 is 2. You can evaluate it with your calculator. 3 factorial is the same as 6. 3 times 2 times 1. So 2 goes here. We'll have this as plus x cubed over 3. 4 factorial is the same as 4 times 3 times 2 times 1. So that will give us 24. That will give us 24. So 6 here, we have this as minus x raised to power 4 over 4. 5 factorial is the same as 5 times 4 times 3 times 2 times 1, which is the same as 120. So simplifying this, we'll have minus x raised to power 5, all this over 5. Okay. And yeah, we just needed the first 5 terms. And that's how we get the Maclaurin series expansion for ln1 plus x, or the power series for that using the Maclaurin's theorem.